Alright, in this video we're going to apply mesh analysis to this 8 resistor circuit here. So looking at the circuit, we have E, the supply voltage, which is 100 volts, and then we have 8 resistors in here, and these 8 resistors are set up with basically 5 meshes. So if we look here, we can see there's 5 windows or loops around, and we're going to call them A, B, C, D, and E as labeled here. And the notice that the loop currents are going in a clockwise direction. Also notice that I labeled the different windows in a clockwise direction. So you want to try to be as consistent as possible when you're working through this. So what we want to do is we want to create our R matrix. So remember, we're going to have an R matrix, R times an I matrix, and that's going to equal to our voltage matrix. So we have a resistance matrix, a current matrix, and a voltage matrix, which gives us effectively Ohm's law. And so we have 5 different loops. So this is going to be, the R matrix is going to be 5 by 5. Okay, the R matrix is always square, and the voltage and the current matrix are going to be 5 by 1. So they're going to have 5 rows but only 1 column to them. Alright, so what we need to do, the easy way of doing this is that we're going to create the A row, which I'm going to do in red. And what we're going to do is just go along here, and we're going to look at all the resistors that A is touching, okay, and add those up. So we're going to have the 8K plus the 2K, and those are the only 2 resistors. That's resistors R1 and R2. R1 and R2. Those are the only 2 resistors that are touching A. Now we're going to subtract off all the resistors touching B, all the resistors touching C, all the resistors touching E, and all the resistors touching D. And actually we need D and then E. We need to make sure we do it in the correct order. But if we look, B is touching R2. So we're going to subtract off R2, which is 2K. But C, D, and E, well, especially C and D aren't even touching A at all. And E is only touching it right here at this one little spot, but they're not sharing a resistor. And so therefore, C gets a 0. Technically it'd be a -0, but it's just a 0. D gets a 0, and E gets a 0. Okay. And that's our IA. And let me see if I can scroll down here just a little bit and finish this matrix, but leave plenty of room so I can fit it all on here. So that's going to be our IA, and then that of course is going to equal our voltage. So we're going to have our voltage there, and so we look and see what power supplies, what voltage sources we have in the mesh analysis. Now, one thing I should point out, this circuit only has one power supply, which is E. So we only have the one power supply, which is E, and it is touching A, and it's pushing, it's going in the direction that A is going, so it's going to be a positive 100 volts. Okay, so this is our I matrix and our V matrix, and this large one is the R matrix. Alright, so now we're going to go to loop B. Now loop B is touching R2. So now remember that we always have to be symmetric here. So this -2 here and then the 3 zeros are going to go down the row there. So I'll just so this is my B row, and so I'm going to have the -2K here, which is due to R2. Alright, so we always have this symmetry happening here. And then in the B, this is the B column, and this is the B row. And so that's where I put all the resistors associated with the loop current B. And so that's going to be R2, R4, and R8. So R2, R4, and R8. And we just add those up. So that's going to be a 2K plus a 3K plus a 2K. Alright. And then now we've got to subtract the C column. This is the C, D, and E columns. Now B, we've already subtracted the A column. But B is also touching C right here at R4. So we need to subtract off R4. We need to subtract off R4, which is 3K. Now, B and D only touch at this one point. Okay. Now those E's up there are... let's see, this E was left over from the previous when I was marking the node, so let me delete those. But the D and B are only touching by this node, so they're not sharing a resistor. So there's a -0 there, and you really don't have to put the minus because it's simply 0. So -0 and +0 are of course the same. But B and E do touch right here at R8. And so we have to subtract off R8, which is going to be -2K. And that's our IB. And there's no voltage supply there, so that's simply a 0. Alright, so now we're going to do the C. Okay, and so we're going to do our C. And C here well, we've already, remember, C is not touching A. C is not touching A, so that's a -0. C is touching B right here at R4, so that's this one here. We have to match that, so that is going to be a -R4, which is a value of -3K, and I forgot to put the K in there before. Okay. So these are all K's, so you know, you just need to be consistent there. But that's 3K, and then all the resistors touching R. So this is the C column and the C row. C column and the C row, that's where we put all the resistors that are touching the C loop. And so that is R3 and R4. Okay. And so that's going to be a 3K plus a 6K. Okay, we add those ones in there. Now, C and D do touch, but they don't actually share a resistance. Okay, so there's no resistor here. It's just a conductor that we assume has zero resistance. And so C and D, this is the C row but the D column, those do touch, but there's nothing there but conductor. So again, it's a 0. And C and E, they only touch right there at the node. So again, they don't share a resistor, so that's a -0. All right, so this is my current IC, and there's no battery in loop C. So there's no voltage source in loop C. So that just goes right there. All right, so now we're going to do D. So we're going to do row D. Row D doesn't touch A at all, so that's a -0. Row D does touch B, but only at that node, so they don't actually share a resistance. So again, that's a 0. D and C, we already that's what we just talked about. They share that conductor there, but there's no resistance. Okay, so that is the C and D. And then D, so this is the D column and the D row. And there, that's where we put in all the resistors that D touches. So that's R6 and R7. So that's R6 and R7. And so that's a 6K and a 3K. And then D shares R6 with E. Okay, so the E and D here share R6, which is a 6K. And that's current ID, and there's no battery in there, so we just put a 0 in the voltage. And then E was blue, so change to blue here, and we'll do E. So row E now, E touches A, but it's just a node, there's no resistance there. So that's a -0. So again, notice that this column here going this way matches this column here. The -2, 0, 0, and 0 match. All right. Likewise, if we look at the B, so if we look at B and see. Oops. If we look at the EB, we see a -2K there. So those are being shared. So you see that right here. You see, so now we're at the BE. So we have the BE and the EB. Those are both have to be the same, right? Because we're sharing this resistor R8. So that's resistor R8. So we're going to subtract off resistor R8, which is a -2K right here. Now we've got E and C. Now E and C only touch at that node, so there's no resistance. So that's a -0. And then we've got D and E. D and E share R6. So we get a -R6, which is a -6K. All right, so again, when we go E to D, and then D to E, these two are a match. All right, and then now we just have our E column we have our EE column. And the EE column is everything touching E, which is R8 and R5. So we'll put R5 first for numeric order. R5 plus R8, which is plus R5 plus R8, which is 8K plus a 2K. And that was my IE column. And again, there's no battery in there, so you put a 0. Alright, so this is our equations here. We have 5 equations and 5 unknowns. Our unknowns are the currents. All right, we know all the values of the resistors. We know all the voltages, in this case just 1 voltage, but we know both of those. So now we just have these loop currents. And so we can solve this if we go to our Octave program. And let's see if I can fit them both on the screen here. It's going to be a little bit complicated, but I can scroll down and do the first row first. So I'm going to have my resistance matrix is equal to bracket 8 plus 2. Now remember, I've got K's in everything. If you double check and make sure if everything is like kilo ohms, you can leave off the K's. But if it's a mix, some are kilo ohms, some are ohms, maybe some are mega ohms, then you can't leave off the K's. And remember, if you do leave off the K's, then you need to basically, your currents are going to be in milliamps. So if you end up with 2,000 milliamps of current, then that would be 2 amps. But just remember that if you leave out the K, then your current is actually going to be in milliamps. But here we have our 8 plus 2, and then we have a minus 2, comma 0, comma 0. And again, I could put a negative sign there, but it's really unnecessary. Alright, now I could put a semicolon here, or you can actually just hit enter and type it on another line. That's valid also. Alright, so now we're doing the second row down here. We're going to do this row, which is the B row. And so that's going to be the minus 2. And then we have 2 plus 3 plus 2. Then we have a minus 3, a 0, and a minus 2. And then we have the C row. So now we're doing the C row down here. And so the C is going to be a 0, minus 3, 3 plus 6, and a 0 and a 0. Now we're doing the D row. So the D row is 0, comma 0, comma 0, 6 plus 3, 3 plus 6, 6 plus 3, right? Either one. Missed a comma on that 0 though. Okay, and then comma, and then R6, down here was R6. I missed the minus sign on that. That should be a minus sign. Okay, so let's see, minus 6. And one of the nice things about this Octave program, as I said before, it will show us the matrix when we're done, and we can look and make sure that this matrix is symmetric. So we need to do the E row now. So there's the E row. Down here's my E row. And so therefore we have 0, minus 2, 0, minus 6, and then 8 plus 2. And then we close our bracket there, and here is our matrix. And I'm going to paste that matrix over here for a minute so we can kind of look at this matrix here. And the interesting thing about this matrix is the fact that it needs to be symmetric around the diagonal. So here's the diagonal. Now, you know, the diagonal is whatever the diagonal may be, but notice here we have the minus 2's, and then we have the minus 3's, and then we have 0's, and then 0's and minus 2's further out, and then we have the 0's, and then we have the minus 6's. So when we look at this triangle here, everything in this triangle should be negative, and that triangle should be a flip of this triangle here. Okay? If they're not, your matrix is not correct. Okay? And everything along this diagonal, everything along the diagonal needs to be positive. So those are some quick checks you can do. You can double check to make sure that if it's not on the diagonal, it's negative or 0. And the upper triangle and the lower triangle need to be symmetric. Okay, so then we can build up we come back to our octave. We can build up our V matrix, which is made out of semicolons. So we had 100, and then a 0, 0, 0, and one more 0. All right, so now we can determine our current using Ohm's law in this backslash notation, backslash V, and there are my currents. Now remember, these currents are in milliamps. Okay, now, so the current IA is the first current. So I can get like IA is equal to I1. Oops, I forgot to put the 1 in there. And then we can get like IB is our B current, which is the second one. So that would be I parentheses 2. And we can get IC, which is equal to I3. And so on. Okay, and we can do that for IA, IB, and IC with this software. Now, if we come back and look at our circuit, the current through the resistor R2, right here, the current moving through R2 is IA minus IB. It's the difference of those. So I could then say that I2 is equal to IA minus IB, which is 6.7568 milliamps. And so if we were going to put that in Blackboard, right, we would put 6.76, because to the right of the third digit is 5 or greater. And so we're going to round up this number, and so we get 6.76 milliamperes. That's how we would put that in. You know, if the homework was asking for I2, that's how we would put that in there.